Hey, so it's good to be here. Stockholm has some amazing companies, Dice and Ghost and Paradox and Mojang. So really brilliant place and love seeing you all here. I'm Shanee. I'm a game developer. I'm working at the developer relations team at Google, focusing mainly on games. So that means virtual reality, Android, graphics, play game services, and all this kind of stuff. Today we are focusing on cardboard and virtual reality. My presentation, Senses Override, is a nickname I found for it because this is what the future is probably going to be like. We're going to find more and more ways to override our senses, make believe that we're somewhere else. So virtual reality is coming, just like Noah said. We have heard that sentence for 50, 60 years now, maybe. But, now it's really coming. So we are all familiar with virtual reality. And how many of you watched Star Trek or The Matrix? So pretty much everyone. So you know the holodeck. It's really a way for someone to go and escape somewhere else and explore new places. I'm a big gamer. I apologize for all the Skyrim photos I put here, but I really want this opportunity. I want to be able to fight monsters and feel how it is really like when you look them in the eye and have to run around and dodge their attacks. And what about space? This is a picture from NASA. There is a really beautiful 360 photosphere from Curiosity, the rover on Mars. And the atmosphere in Mars is so tiny and there is no light pollution. So you can really see all the stars. So check it out. Just search Curiosity 360 Mars. You'll find it. It can change entertainment. It can change how we watch films. We can be in the film instead. It's not going to be a cinema anymore. And what if we want to build a new house or decorate our current house? We can just take a plan and make it into a model and feel how it's really going to be inside of it. So there's so many potentials, so many options beyond just gaming and entertainment. They're practical. You can practice surgery without risking anyone's life. Today, this slide is quite old. There's so many headsets out there you can use to experience virtual reality. The most common ones are the Sony Morpheus and the Oculus Rift. Now at GDC, we have heard of the Valve VR HTC Vive headset. So it's really exciting. There is a big community on hacking experiences which currently do not natively support virtual reality. Just downloading some third-party drivers and you can make pretty much any game on PC work for it. Peripherals. We don't just want to see the virtual reality environment. We want to interact with it. You have gloves so you can possibly touch things. You have the lip motion. You can just attach to a headset and see your hand inside the virtual reality environment. Gun controller, and even the virtual Omni for walking about. This is how someone looks like when they're all immersed in,
Did you get one of those?
I have backed the virtual Omni project, and it is coming. I was told it's going to ship soon. I just got my Kickstarter survey. So if you're in London, I'm happy to let you try it when it's there. Well, speaking of trying things, just today, actually, we toyed around in the office, and Noah was playing a game. And the feeling is amazing. Noah can probably...
She told me to smile, and I didn't realize how bad a smile was.
So the thing is, Noah initially put on the whole gear. He put his hands on the joystick and the throttle, and he had his face. It was the most amazing face. When you first see virtual reality, but he's used to it. But the experience when you have all the peripherals correctly set up, and kudos to Frontier, but this is a little dangerous. We're playing there, and they've made the experience amazing. You move the joystick and you see your character moving it the same. You pull the throttle and the character is doing the same, and it fools your brain. The character, you feel it's really you, especially if you set a distance correctly for all the peripherals. So it is really brilliant, and I recommend for everyone to try it out. So cardboard. Well, anyone still don't have one of these? The idea behind cardboard is to have virtual reality accessible for everyone. And this is accessible. You can make it out of anything. The team went to the lab. We have what we call the Makers Lab. There is one here in Sweden, and we have one in London. There is in Mountain View and many other offices. And we just started to experiment with basic materials, just figuring out how you can make it more simple and more simple. And this is the result. This is just a headset and a phone, and some other stuff we'll get into shortly. At Google I/O, we showed this video. We gave attendees this device in a bit of a different form. So you just open it up. Well, we don't have sound here, but never mind. You assemble it, you put it in your phone, and that's it. That's all you need to start experiencing virtual reality. You can make it out of anything. This is an image I found on a Google Plus group. And this is some kind of a morning cereal in USA, I think. And someone just cut it out of it to keep the face. And it's amazing, in my opinion. Just order the lenses from Amazon. People can buy it. This is, again, a very old photo I took. There are so many different sources nowadays. Actually, today I've noticed an article about LG. Every G3 phone that is being sold is coming with the box, actually a cardboard device. So if someone buys a phone, they immediately have cardboard, and that's amazing. And I mean, this is a way to access everyone on mobile and let them experience virtual reality. I was at Devox and I was giving people cardboard and just demoing it. It was just amazing. You see the reaction. An attendee came to me and he asked me, "What's this?" And I'm so used to virtual reality. I've been developing for it for a few years now. I've been playing with it for years now. And I said, "Oh, it's just a cardboard virtual reality device." Just a cardboard virtual reality device. Sorry, just a virtual reality device. Did we have virtual reality 5 years ago? I'm not so sure. So we call it a course of knowledge. When we're used to something, for them, it was the future. For me, it's like, I feel we need even more. We need even better. So yeah. And this is the reaction people have. They try it for the first time and they're so excited. There's so many more technological problems we need to solve, but the way it transforms their view is already amazing. So how does it work? Basically, sorry, these are some photos which are supposed to be removed, but this is what you see inside. You're probably already familiar with it. You have the stereoscopic view and one image for each eye. So how does it work? We have our basic parts. Really, this is lower than $10. I'm not too sure about Swedish currency, I'm sorry. But we have our cardboard for the headset. We have a rubber band, lenses, an NFC sticker, which is completely optional, and a magnet, and some tape. That's the basic components. This is how it is put together. Now, what's our goal? Our goal is to make a believable virtual reality image or experience. So we need to make it stereoscopic and give the perception of depth. So this is our basic setup. We have our user eyes coming to look through the lenses, which focus our wide field of view directly onto the screen, which is drawing our pixels. Then, to make it believable, you don't just want to look at an image and then move your head around and nothing reacts to it. So you have your phone sensors, and we can use them for orientation tracking for the phone. You have your two cameras, one for each eye with a bit of an offset. How many of you are experienced with OpenGL or Unity? You should pretty much know about it. In OpenGL and Unity, we have camera for our view. We set two viewports, we separate them, and we track each of them individually. And then we have our image. And finally, we get our result. Now, you might notice when looking at this image that there is actually a problem. The image is stretched along the edges. This is called pincushion distortion. The reason for it is the lenses. Lenses distort the image, and they make the focus right at the center. So to accommodate for it, we use an opposite effect called barrel distortion, which gives the user the view they're looking for, fixing it. And this is why images in virtual reality have the sort of fisheye lens when you look at them outside of a headset. Now, the question is, how do we interact with the environment? We can look around, but what is an accessible way if you don't have a controller? Everyone can connect one with Bluetooth. And that's where the magnet comes in. By pushing the magnet, we cause a small distortion into the magnetic field. And tapping into the sensor, you detect it, and you say, this is a trigger, just like a button, and that's all. And finally, we want to know if we are inside the cardboard and maybe open our application automatically or change between normal view and virtual reality mode. So that's where the Nfc sticker comes in. So how do you program for it? Using virtual reality and cardboard. There are a few ways. We have Unity, we have Android Java API, we have Chrome and HTML5 experiments. Now, I have a quick sneak peek here to just how easy it is to develop for it using Unity, for example. Some friends of mine from Criterion Games had made this demo and told me it's okay to share it. So this is a spaceship game. We don't have sound, unfortunately. Can you? Oh, sorry, I did not plug it. So, yeah. So the idea is you're a repair drone on a spaceship. And this is actually in multiplayer. So you saw the 3 players. There were actually 4 players. I was at the back, but I was also recording the video at the same time, so you don't see me there. And the smoke you see there are other 2 players flying about. The smoke coming out of the ship is a damaged sector, which they need to fly about and repair. If you can hear the beeping sound, that's like your radar telling you you're close to damaged sector and you need to go and repair it. So the experience, multiplayer experience in virtual reality, that is the first time I've tried it. And it's so weird. You can bump into each other and you see the reaction. You can't hear their sound, but they're actually talking. They're like, I've heard a meteor on the back of the ship. I'll go there. No, I'm already at the back. You go to the front, coordinating and trying, to make sure they complete the level. You can see at the top there is the carrier ship health. And on the left you have, on the left it's the time until the jump to hyperspace. How long do you need to survive? And that's it. They made it within a day. They had a game jam at the office. They just used Unity and the plugin we have for it, and that's all. So the smoke that just fell in is another meteor hitting the ship, and that's the damage you need to go to and fix. Sorry? Yeah. Will they succeed? Will they fail? What do you say? Is the ship going to be destroyed? The fun thing is you see them flying about and you see them looking at each other sometimes, and it's just multiplayer virtual reality experience. It's just crazy. It was actually inspired by a game called Space Team. So the drone just fell on the ship. There is actually another player. So I must say they missed the high five. That's that always gets me. So thank you so much for our friends from Criterion Games. These are the guys who made it. Anyway, if you want to get started and make your own virtual reality experience, it's really simple. You go and get the Cardboard API, or you get either the Java or the Unity API, depending what you're using. And let's have a look at how you do it for Android. I'm going to skip Unity part because I haven't actually made the slides yet. And because it is so simple, it's literally just dragging the camera object and that's it. So for Android, you use Java and our activity. So if you're familiar with Android development, you just have an activity, which is the basic application, or window, which is currently active. So inheriting from Cardboard activity, this makes sure your screen always stays on, because you don't want it to suddenly go dark because you can't interact with the button because the screen is inaccessible. You always want to be in landscape mode. You're moving your head quite a bit, and if it suddenly changes to portrait, that's really disorienting. And some other features like hiding the menus, because that's wasted pixels. You really want to use all your screen. You need to make a renderer. The renderer is implemented with OpenGL, although you can also use libgdx, for example, if you want to go into that route. There are 3 functions you need to overwrite. We'll get to each of them in a moment. On new frame is pretty much your update. That's where you put your game logic, updating AI and physics. You have your on-draw eye, which is, back to here. The head transform gives you the orientation, and you can also set the camera if you need. On-draw eye, so that's where we make our view projection metrics for each eye. So like I mentioned, each eye needs to be in an offset to get the stereoscopic 3D effect. So this computes it for you and gives you the angle and the view and the position for each of them. So you combine the eye metrics with your view metrics to get that offset, and then everything else is normal. You get the world metrics for your object and the perspective for the eye and for the actual screen. And then you draw the scene. So this comes up twice, one for each eye, and that's how you get the view, how you get this stereoscopic effect. Next, for the magnet, there is a simple function to override, which is this on-cardboard trigger. And then because you only have one function, you need to really make use of it. So if you're in a treasure hunt application, for example, then if you're looking at the treasure, you want to pick it up. But if you aren't, you might want to show the map. Although a cooler implementation is actually that when you look down, the map should just show up, because that's more intuitive. And finally, the Nfc Sticker. If you want to identify that you're in virtual reality mode, or maybe just open your application when you put it in Cardboard instantly, then we have this simple API which detects if it's touching the sticker or not, which you can change between virtual reality mode and normal mode. And you can program for this default which is what's in the sticker that comes with our cardboard. And then you can use in the Android manifest XML, you can set an intent to just open your activity automatically. So that's about it for how to program for it. This is quite simple. The rest is your engine and your game. But there are some best practices. I mean, this doesn't really work very well, does it? So virtual reality is different from normal applications. You need to correlate for motion. Never, ever stop the camera's orientation from changing. If you have a menu or a loading screen, make it interactive, make it immersive and 3D. Put them in a waiting room or something to fit into your game. Always keep refresh rate at 60 frames per second at minimum. Some devices are capable of higher, but never go below. That's just not a good experience if your image is jittery and you have nowhere else to look at. And finally, you have a seemingly infinite screen. The experience can be so immersive. Make sure to use it. Put things all around the user. Make sure they can look around. Make sure they can look at the back and immerse them. And this is a different experience. This is no longer looking at the screen. So take use of it. And remember, like we said, this is real for now. We see it happening with so many companies. Like Noah said, if it was one company, we would be skeptical. But we have low-cost devices. There are so many companies and working on it, and the technology is very well proved. So give it a go and explore new places and try things no one else have done before. New frontier. This is completely new technology and exciting thing to do. That's all. So thank you for listening.